Okay, this is page 63, number 4, in our quadratics unit we're working on. A worker accidentally drops a hammer from a scaffolding of a tall building. The worker is 300 feet above the ground, and as you answer the following, recall that an object falls at 16 t squared feet in t seconds. So I'm going to do this a little bit backwards here. The first question is, how far above the ground is the hammer falling after 1 second? After 2 seconds, and write a formula. So first thing here is, if we have the height is 300, and it's falling towards the ground, so it's falling actually 16 t squared feet per second. If you subtract that from the 300, we'll have how high above the ground it is. So in 1 second, we could just substitute a 1 into our t squared here, and you end up with 300 minus 16 times 1 squared. Well, 1 squared is 1. Times 16 is just 16. So the answer for 1 second would be 284 feet. Okay, now for 2 seconds, same idea. We can go 300 minus 16 times 2 squared. Now don't forget, you have to multiply the 2 squared first. So 2 squared has to come first. So that would be 16 times 4, which equals 16 times 4 is 64. So 300 minus 64 is 236 feet. And then on A, it said write a formula that expresses the height of hammer H after it's fallen for t seconds. So I could take my expression here and set it equal to H, and we're good. That would be our formula. Now for B. How many seconds does it take for the hammer to reach the ground? How many seconds does it take for the hammer to fall until it's 100 feet above the ground? So now we're just going to use that formula we have, which is 300 minus 16 t squared equals a number. Now the number here is how high it is off the ground. So if we want to know how many seconds it takes for the hammer to reach the ground, the height of the ground is 0. And if we solve that, that will give us our time, t, solve that for t. So let's go ahead and let's add the 16 t squared to both sides. So we get 300 equals 16 t squared. Divide both sides by 16. And we end up with 18.75 equals t squared. And now we could square root that, and then t would equal the square root of 18.75, which is about 4.33 seconds until it hits the ground. And we could do the same thing for how many seconds does it take for the hammer to fall until it is 100 feet above the ground. Same equation, except instead of a height of 0, we want to see when the hammer's a height of 100. And we could do pretty much the same thing. I'll actually subtract the 300 first, just to show we can do that. So we end up with negative 16t squared equals negative 200. Divide both sides by negative 16. You get t squared equals 12.5. Take the square root of 12.5, square root both sides. T equals 3.54, approximately 3.54 seconds. There you go.